Good. Thanks for being here. We're going to kick off on a timely topic, maybe not as localized as the bridge or the waterfront. This is going to be a little broader. But I'm going to start off by asking the audience some questions, because as the Financial Accountability Officer, which, by the way, I'm not part of government, we work for the Legislative Assembly. We provide economic and financial analysis to that body, and we publish our work for the public. It's on our website. So a couple easy questions to start with. How many municipalities are there in Ontario? 444. All right, that's the easy one. Perfect. And how many provinces are there in Ontario? Well, actually, that's an easier one. Okay. All right. How many, if you were to take all of the provincial and municipally owned buildings and go and buy them and replace them all tomorrow, how much would that cost? $254 billion in 2020 dollars. If you were to take all of the transportation infrastructure, roads, bridges, culverts, rail lines in Ontario, municipal and provincial, what would that cost to replace tomorrow? $330 billion. Okay, so there's a lot of stuff in the ground already. So what I'm going to start with is just going to lay out a bit of a baseline in terms of what we found on our work on the impacts of climate change on these billions of dollars worth of infrastructure. And then we're going to turn to our panelists who all come from different kind of aspects of this problem and talk about how they see the problem from their lens. And if we have time, which we probably won't, but if we do, I'd like to get a few ideas from the audiences and all of us how we tackle this problem. So we lay out the costs in our report to maintain. So what happens with climate change really quickly? You have heat, and it gets hotter and hotter over the course of the century. That also brings with it excess rain, so a lot more rain. We'll have also slightly fewer freeze-thaw events than we've had in the past. And what that does is effectively it wears out these infrastructure assets more quickly than if that climate change wasn't present. To the tune of, for buildings, it's about $10 billion per year extra, and I think the road's about 12 and change billion per year extra that you have to factor into your regular maintenance. So it's a pretty significant. You know what? I don't think I have that number quite right, which don't tell anybody because, I should. So basically, it's 13 billion per year on the road. So you're already spending, most of that. That 13 is already being spent. So, sorry, let's try that again. 13 billion is what you're spending on roads in a high emission scenario, i.e. if the temperatures keep rising at the rate they're rising now, you're going to have to add an extra 4 billion per year to that. Okay, so I know a lot of numbers and I went and gotten them all confused, which doesn't help anything. Bottom line is it will add a significant percentage to the ongoing maintenance to manage these assets. But what we don't include in these numbers is what happens when if this infrastructure should fail. So in our reports, which are available on the site, we talk about cost benefit in terms of if you are to spend money now to adapt the infrastructure, what sort of savings would you have over the long term on just strict operations and maintenance costs versus if you don't. And you'll find on the buildings, it's kind of marginal. On the roads, there's this reasonably significant savings, but we don't include in that is what happens if that road gets washed out and you have a community cut off and you have big economic dislocation. So if you are adapting, not only are you going to save some money on O&M, but you're also going to make your infrastructure more resilient to the potential effects of climate change and try to avoid some of these big catastrophes. So that's what our report does in buildings and transport. Water is going to come out in probably December. And then my team can get back to what we regularly do, which I'm not sure what that is anymore, given we've spent so much on climate. But it's been a very interesting piece of work. It was requested from an MPP from the Green Party about 2.5 years ago. And my team of 20 have been working on this, so a lot of them for that period of time. I'm going to stop now. I'm going to turn it over. We'll start here with Stephen on my right. You can introduce yourself quickly and then do your piece, and then we'll just move along to Yeah.
Wonderful. Well, thank you very much. I'm Stephen Turner. I'm a city councillor for Ward 11 in the City of London, Ontario. I spent a number of years on the city's Planning and Environment Committee and also on the Civic Works Committee. So I've been really passionate about the environmental impacts of climate change on our municipalities. I'd ask all of you there's a number from the municipal sector, but you all live in some municipality. How many of you come from municipalities that have declared a climate emergency? Okay. So in 2019, the City of London declared a climate emergency, and sometimes there's a lot of discussion about whether that's something that's just kind of in words and not in action. And for a few years it was in London. We declared the emergency and we didn't really have much action to go with it. But one of the first things that came out of it was the development of the Climate Emergency Action Plan for the City of London and something called the Climate Emergency Evaluation Tool or Screening Tool. And the first application of that was to take a look at 10 major infrastructure projects, major transportation infrastructure projects. And when that tool was applied, we ended up killing 2 road widening projects in the city. We had a major road that was going to go from 4 to 6 lanes, and another one that was kind of 1.5 on each side, so 3 to 5 lanes roughly. And under that toolkit, we ended up saying no. And the toolkit, the screening, kind of looks at, will this project help reduce the number of trips taken by single occupant vehicles in London? You widen a road? No. So some big, really interesting approaches to that. We've got to take a look at climate impacts, as was just mentioned, one on our infrastructure. If we have to repair it or we have to harden it, how does that figure into our budgets and our corporate asset management plans? And 2, how do we reduce the amount of carbon outputs our municipalities do through the way that we design our cities? So those are kind of the things that I guess as we talk through the panel that I'll be focusing on a fair amount.
Hello, everyone. My name is Dr. Apeksha Gupta. I'm the Design Program Manager at Toronto Community Housing. I'm actually in the Facilities Management Division. Our division actually helps in asset renewal. As if you all were awake in Michael Lamb's introduction of Toronto Community Housing, he did tell that we are the largest social housing provider in Canada. We own around 2,100 buildings and we're a $9 billion public asset. So his team in development develops new buildings. I mean, it's basically revitalization projects. What our division does is maintains those assets. So we have to look at those assets, see which are reaching end of life, and then regularly maintain them. Regularly maintaining assets and asset renewal also has a climate, we have to make them resilient to climate change. And so I'm going to be speaking about how do we make our buildings more resilient against climate change. What we actually are targeting right now are more comprehensive retrofits. So I'll try to touch base more on that as I go forward. What we're currently doing is whatever funding we are getting, the larger proportion of that funding is more energy-based funding, which means that we are getting energy-based funding to do retrofits with a clear mandate on energy reduction targets. If you don't meet those targets, the funding is converted into loans, which is what you don't want as a social housing provider. So basically, a large portion of our funding is right now energy-based funding. What we've realized over the past years, we have around 5 years of energy performance-based retrofit experience to bank on. What we realized over the years is part or like-for-like replacement. If a boiler breaks down, replace the boiler. If the windows are leaky, replace windows. That's not the answer to a retrofit, to asset renewal. It's about dealing with it comprehensively, looking at the entire building and seeing and prioritizing the capital repair such that they align with your expected energy of performance outcomes. So, high priority buildings, if they're end of life, you you basically you target those to sort of get that anticipated energy performance outcomes. So I'll be talking more about these as I go, and welcome suggestions on it, suggestions and questions and clarifications on that as well.
Thanks, Fish.
Hello, my name is Dean Rurak, and I'm currently on the board of directors for Asset Management Ontario. And I'm also the director of corporate asset management for the regional municipality of Niagara. My introduction is going to be a little bit shorter, but I would just comment that the perspective that I'm bringing is obviously from the regional municipality of Niagara, but as well a lot of the other 444 Ontario municipalities. And just to add a little bit more to the composition of the municipalities that we have, as I recall, the median population for the municipalities is somewhere around 15,000 people. So a big challenge for Ontario is how, as a small municipality, do we manage what potentially is a very large problem? Thank you.
Okay, thanks. Nicole.
Good morning, everyone. I'll also keep my introduction short. My name is Nicole Yardy. I'm the climate change specialist with the town of Collingwood. And before accepting an invitation to speak on this panel, my first question was, where does infrastructure intersect with climate change? And why would I come to an infrastructure conference? So through that, I took a look at our greenhouse gas inventory for the town of Collingwood. And similar to most municipalities in Canada, buildings and transportation contribute the most emissions overall. So in Collingwood, it's over 40% of our greenhouse gas emissions come from building. Again, another over 40% come from transportation, and the remaining 5% is waste. So that building and transportation infrastructure is really exacerbating the problem when it comes to climate change. So where my focus is how can we build a more resilient infrastructure base while also rethinking design and rethinking the integration of green infrastructure in our new designs and buildings.
All right. Well, thank you for that introduction. So any questions at the moment that people can think of that they want to throw out there? Because if not, we're going to carry right into how we start to wrap our heads around this municipal problem. So I've kind of laid out the dollars, and these are basic, very conservative dollars. This doesn't assume things like flooding, doesn't assume things like windstorms and freezing rain, et cetera. So the dollars are actually going to be quite a bit bigger. But why don't we start in terms of kind of how you guys are thinking about approaching this challenge?
Thanks. So it's really a challenging question, right? Because when we take a look at our corporate asset management plans, the costing has been not really done with a climate lens on it. And if we know that a bridge is now going to last 5 to 10 years less, do we change our amortization schedules of that? If we're taking a look at, we had a major flood event in London about 5 years ago, and we're coming close to cresting over our major sewage treatment plant with our river. And if you can't shore that up, then you've got pretty disastrous consequences. We almost had to close one of our major bridges because we weren't sure if it was going to be able to withstand the water pressure. And so we have to then now calculate that to our target hardening. CBC just had an article the other day on the news that was talking about how tornado researchers were recognizing that the epicenter for tornadoes had kind of shifted a little more eastward from Saskatchewan towards Ontario. So you can imagine the difference between a rather unpopulated, low-density area now having significant weather events in higher populated areas. Do we start to take a look at how our building code changes to be able to be resilient to those things? I'm also a paramedic chief, and we're looking at building a new headquarters. In doing that, all the buildings that we build now have to be post-disaster certified. So that means that the roofs don't come off in a tornado or heavy wind events. So our cities prepared and municipalities prepared to take a look at those and start costing them and start adding them into their budgets. And as a politician, the answer is usually always no, because we're always have this downward pressure to keep taxes as low as we can. But if there's significant costs and we're going to lose infrastructure as a result of these climate change events, then I don't think we have much choice. We all know about the infrastructure gap, but the infrastructure gap is probably a lot larger than we think once we start to calculate in climate change impacts.
Did you want to say anything?
It's actually all about, I feel, wherever you're investing that taxpayer's dollar, that needs to be sort of well thought out. That spend has to be well thought out. What we do in our buildings is, we can't replace every single building. We can't tear down every single building and build new. Imagine the impact. Like, we have a zero carbon plan. Imagine the impact that would have in sort of carbon emissions and our roadmap to net zero. So we can't do that. So what do we do to maintain our assets? Maintain our assets to an operational level. So what we do in terms of what I was talking about in terms of comprehensive retrofits was, our buildings are occupied buildings. They are vulnerable tenants. So they require thermal comfort. You just need to make your buildings thermally comfortable. The idea behind is not to provide heating and cooling, but to make the building resilient so that you don't require heating and cooling. What we do in our comprehensive retrofits is really focus on the envelope. If the windows are leaky, we just don't replace the windows. We do overcladding as well, because we know it's just easier to do a blanket on the entire building, and it's just better for the building's thermal performance. We then couple that with ventilation upgrades, because we don't want a tight blanket around the building, and then the building is not being able to sort of when the moisture builds up, you're not ventilating or exhausting it out. So you need to tie that with ventilation upgrades. What envelope upgrades do is then reduces the size of your heating and cooling systems, which actually puts less the pressure to utilities infrastructure. So that's what the energy efficiency pyramid or a net zero pyramid is all about. It's envelope upgrades, reduce heating loads, meet those with low carbon heating and cooling solutions, and then whatever else is left which requires energy to run those from on-site renewables. That's literally the roadmap to net zero. But what we face in our buildings is the scalability of it, the funding for it. We really require funding, because more and more energy-based funding needs to be targeted more towards net zero, because the targets then just become massive. It's 90% energy reduction on your building and things like that. So currently, for Toronto Community Housing, we haven't achieved that goal of energy-based funding, but we are looking for funding partners who help us achieve that goal. We are trying to align ourselves with the City of Toronto's net zero plan. We're trying to make our strategies ourselves. But yeah, it all comes down to funding and where that top dollar, the top taxpayer's dollar is spent and how it's spent. Another key thing about the way we do retrofits is always do an integrated design process. We involve the entire project team and all the stakeholders really early on in the scoping and design of the project, which makes basically, if the design is resilient, then you are not losing money in construction because of poor design decisions made. So we've sort of protect ourselves with that, as well as do an in-depth cost-benefit analysis. Because it's taxpayers' money that we're spending, we have to, every dollar spent is questioned around metrics like return of investment, total cost of ownership, which enables TCHC to do informed decision making. And in order to do informed decision making, is just not us working in silos. We work with the industry. We work with Michael also touched about the scalability of it. Is the market ready for it? Do we have enough trades? Do we have enough manufacturers to take up the scale of it all? We also are tying up with research partners, because a lot of what we're doing are pilots and which needs to be documented and with hard evidence that these actually work. So a lot of measurement and verification happens post our retrofits to understand what the actual benefit of it is, because tenants are involved. You will design and construct a building up to a standard, be it passive or net zero, but it's ultimately down to the tenants on how they operate it. And the more you educate them to behave in terms of occupant behavior, the more the buildings would actually operate the way you designed them to.
Great, thank you. So that's buildings. So Dean, I guess you can. That's an interesting piece on buildings. Just as a quick aside, we did some work on terms of as part of these reports, and the found that I found interesting was when you reduce the emissions, you reduce the energy cost. At that really high level that we did the report at, you'll see the difference in an incremental cost between a medium and a high emission scenario is about double. So yeah, reducing emissions really gets us. And part of the reason for that is that as emissions go up, they build up in the atmosphere. So if you're able to get those emissions down more quickly, then you reduce the rate of buildup. And that really has a big impact 80 years out.
Okay, thank you. So there's a saying that I like, if you're a hammer, everything looks like a nail. So the focus of my discussion is going to be on asset management planning as a process to help frame climate-related infrastructure decisions. So since we're talking about asset management, I'm going to start off with what asset management is and a couple of questions, and these aren't rhetorical. So not the industry standard definition, but a question. Is it the lowest cost infrastructure? So as I say, it's not rhetorical. So is that what asset management is, the lowest cost infrastructure? Anyone? Don't be shy. Do you think it's no? So we heard a no, and I'd say, yeah, no, it's not about the lowest cost infrastructure. How about the lowest cost services? Getting some nods, maybe yes. Well, no, it's not about the lowest cost service either. Is it sustainable services? Yeah, it's definitely about sustainable services. So at a desired level of service or prescribed level of service or reasonable, rational level of service. So we hear a lot about affordability. So is affordability an issue? Yeah. So most people are going to say yes, but I'm going to say no. No, it's not about affordability. Because you should deal with affordability on an individual basis through policies. So that's a little bit perhaps tongue-in-cheek, but asset management is theoretically about willingness to pay, not affordability per se. So today, there's going to be a lot about resiliency and sustainability, and so we'll just talk a little bit about what sustainability is, the ability to maintain or support a process continuously over time. And then resiliency is the ability to recover quickly from difficulties. So obviously those two things are very tightly integrated. So if we've identified that we want sustainable services and those services are supported by assets, then it's rather obvious that our assets should also be sustainable. So how do we go about ensuring sustainability? So that's an open question to you guys. Any thoughts or ideas on that? So we said resiliency, yeah. So if resiliency is about adapting and recovering, then that's got to be part of sustainability. Anything else? I'm sorry? Rate structures, okay, presumably appropriate and so forth. Anybody else? So we did hear something about something coming down to funding, and really, that's sort of the bottom line, right? The bottom line usually is about money. And if a service is not fully funded or an asset is not fully funded, then sooner or later it's going to fail or it's going to fall to an unacceptable level of performance. So it really means that irrespective of anything that we might think about for sustainability, it comes down to being fully funded. So another audience question, there's folks from municipalities or governmental organizations. You have assets, you've identified in some fashion the performance of those assets and then what would be required to sustain them in the future, but then presumably also bring them up to snuff. So in your organization, do you have an infrastructure backlog right now? Yeah, pretty much that's across the board in Ontario and presumably Canada and presumably North America and so forth. So we have the backlog now, And in determining what that backlog is, have you incorporated the cost of climate change into that backlog? And most people probably have not. Okay, so we want to be fully funded. We have a backlog now. We talk about affordability. Every municipality, every politician, no offense, talks about affordability and reluctance to increase taxes. And on top of that, now we have these additional costs potentially coming from climate change. So we framed now that our discussion is around a problem of funding. So how do we go about solving that? So remember, our theme is about asset management. I'm not going to talk about those specific steps, but rather a problem-solving approach with just 3 steps. What's the problem? What will happen? And what is the probability that it will happen? That's important. And then so that addressed generically and then specifically. It has to be generic at some level because individually we can't afford to figure out this whole climate thing on our own. So the industry, the province, the different levels of government, et cetera, has to kind of figure that out. And there's been a lot of work done with respect to that. And then we have to figure out how to translate that specifically to me or to my organization. And so now that we understand that, what's the potential solutions to the problem? And one thing that's nice about Ontario's, the MOI's guideline for asset management plans is that they very specifically identify that you should be looking at asset-based solutions and non-asset-based solutions. So we talked about conservation. That's obviously an important part of the equation. But for an example later, I'll talk about an asset-based one. So then finally, that we understand what the problem is and the scale and its magnitude and probabilities, on what scenario will I base my funding? Is it going to be the worst case, the best case, something in between? And then how then are we going to translate that information into funding? That presumably needs to be equitable. And another part of the definition of sustainability is to not transfer these problems into future generations. So somehow we've got to figure out a balance on that, and we're going to do that through some sort of scenario analysis. So I did look at the FAO study, and I find it quite useful from the perspective that it's very discreetly identified what potential changes could happen on an asset basis, and with some numbers, which is really important, trying to figure out the scale and magnitude of the problem. And what they do say, of course, is there's a large caveat. There's limitations, assumptions built into that, but they do say that because of the significance that the information is relevant for Ontario's long-term infrastructure and capital planning. So we can use that information. And of course, now we have to take it with a grain of salt. So now let's look at our problem-solving approach and say, number one, what is the problem? So generally speaking, we know what it is. We have these acute events that happen, and as a result, it impacts our infrastructure, causes asset failures, and much larger than just infrastructure events. It's also causing problems with air quality, population migration, et cetera. So from the FAO study, the study that Peter was mentioning, the 2 ways that they've identified that climate change will impact infrastructure are damage costs, which would be either failure, consequential cost, or increased deterioration, which reduces your useful expected life. So in both cases, you're going to end up with a cost, increase in cost. And then there's the adaptation cost to say, okay, we understand how this is going to happen and what effect it will have. So how can we prevent that bad thing from happening? So that's a retrofit of an existing asset or a replacement with new or hardened assets. And altogether, again, we're talking about an increase in cost. So when we look at it from an engineering perspective, it's an engineering problem. Like, what do we have to do to this asset to make it work better? From a corporate asset management perspective, it's really more a sort of economic decision. And again, it's coming down to funding. There's always a need for more funding for one thing or another. We've got to figure out how to sort through all of that. So secondly, then, what's the potential solutions? And so I'm going to use bridge as an example, and this is again from the study. So the impacts relate primarily to increased need for erosion protection, runoff control and drainage, and renewal of shallow foundations. And I would also note that any upstream flooding issues is not addressed in the study. So we're just talking about the actual bridge itself. And anything that happens outside of that is not part of those costs, but obviously something that we would have to deal with. So for bridges from the study, extreme rainfall may cause a reduction in USL between 5% and 10%. So they give you a range with a most likely value of 7%. A renewal cost increase with a most likely value of 6%, and a cost of retrofit with a most likely value of 6%. So we have some percentage increases. And there is, what I would say, what I found surprising is the expectation that there'll be a reduction in freeze-thaw events, which is a plus, as they indicate that should result in an increase in bridge useful expected life of most likely value of 3%. So we have two pieces of information there: a reduction of, I think I said 6% because of extreme rainfall, and an increase because of reduced freeze-thaw. So one might be inclined to just go 6 minus 3, 3% reduction. However, I would say, well, you have to treat it as two separate events with two separate probabilities, and then figure out how to treat that information. So that's all general information that's available to everybody. So now we have the ability to start using that in our planning. So we'll take an example for me specifically, meaning me as an organization or you as an organization. So we have a bridge that we've built over water for $20 million 35 years ago, and it should last at least 50 years. So when it was built, it had some design parameters, including a storm flow, resistance to erosion, possibly resistance to rebar corrosion, to accommodate some traffic volume, and various other factors. Okay, so that's as it was built at that point in time. And now we have enough information to suggest, well, there's going to be some impacts from climate change, and we have an ability to use that information to figure out what that's going to result for this specific bridge. So here's the numbers, and this is going to be somewhat difficult since you don't see it in front of you, but we have our example bridge. It's 35 years old, USL of 50, useful expected life. So it originally cost 20 million, and we'll say, well, now it's worth 30 million. But that's without factoring in climate change. Right? That's just sort of regular cost of living increases. So retrofit should be an additional 1.8 million, right? So we can retrofit it to protect it from rainfall events for $1.8 million. And we've lost 3 years in its replacement time. So instead of replacing it in 15 years, we're going to replace it in 12 years. That's going to cost of money, $1 million. And then when we go to replace it, we're going to have to spend another 1.8 million. So that matches up with those percentages from the WSP report, or the FOA study. So altogether, that's an increase of 4.7 million, or 16% for this bridge. Okay, so that in theory is what we're dealing with. So now we go to number 3, on what scenario will I base my funding? So now we have to look at it in two perspectives. So I have one bridge where I have this information, but I also have many other bridges. Maybe there's 5 in my municipality, or 10, and of those, 2, 3, 6, 7 cross over water. So I can use those numbers at a certain level to figure out, okay, the total financial cost over the life of all of these different bridges, depending on their particular parameters. And then there's the information for this specific bridge and what I'm going to do for it. So do I take all of the project's costs at the most likely outcome for each of those asset types? So potentially, pretty high potential that I'm going to end up having to have more taxes. And then that has to be offset somehow. And it could be then offset from the customer base, from the residents, through a reduction in personal quality of life changes. Well, we're just going to have to pay more taxes, and I guess I'll take less vacations. Or do I take all of those projects' costs at the most likely outcome for some of those asset types? So I say, okay, well, I have a number of bridges, and it won't apply to all of the bridges because some of them will go over water, and maybe that won't happen for every bridge that I have. So there's less potential increase, but potentially also some higher risk of asset failure. So I could say, well, I might apply to all 6 bridges, but what is the likelihood that all 6 of those bridges would have the same failure impact? And if I think that it's high and I can cost that, or if I say, well, I'm willing to take a little bit more risk and say, well, in all probability, it's not going to happen to every single bridge. So maybe I'll roll the dice a little bit and only fund for a certain amount of that to happen. So the illustration really is just to say that there's a certain amount of uncertainty, and we have to build that into our decision-making process, because we're talking about a significant amount of money, right? So in this one case, it's 15% increase in a pretty short period of time. So just from let's say a more immediate perspective, we have to replace it in about 12 years. Okay, so let's say that this is today, right? We have this bridge that we have to replace in 12 years, according to the numbers, or 15 if it doesn't turn out quite the way we anticipated. So that retrofit, should I do it or not? Should it be in my 10-year capital plan? That's $2 million. Should I put it in there, or should I say, well, I don't know if it's going to happen. Sure, everybody says it's going to happen. Is it really going to happen in the next 10 years? And should I really put the money in my budget? Should I really do it? And it comes down to, okay, who's making that decision, and how comfortable are we with the level of uncertainty and risk in that decision? Because we're talking about real money, and we're asking for real money from taxpayers to pay for it. Okay, so let's come back around to how do we go about building sustainability and resiliency and answering that fundamental funding question? And I postulated, being a hammer, that the answer is asset management planning, and that we have to use risk, level of service, and cost. And I say, well, we already have that in place, right? We already have asset management plans in municipalities. In some cases, it's a legislative requirement, certainly in Ontario. I'm not sure about the rest of Canada. And in all cases, there's incentives through funding grants of various sorts to have asset management in place. So why would we not use that process and treat climate change as one more risk that we must address? So asset management asks and answers 6 or 7 questions. What do I own? What is it worth? What are my levels of service and risk? How much risk can I tolerate? What do I need to do and when? And how will I fund it? That's what asset management is doing for us. So great, we're all set. Well, we still have a few more problems, 2 more problems at least. The first one is that we haven't institutionalized asset management as a process. For the most part, what we do is, well, we have to do an asset management plan. Okay, let's pretty much start from scratch, pull all this information together, put it into a report. It's a snapshot in time. So inherently, there's nothing really wrong with that, except that if we have to be adaptable and nimble, we can't afford to spend 6 months and a lot of time and effort producing a plan that could change in 2 or 3 years. So if we're really successful with all of our climate initiatives, reducing energy, GHG, et cetera, then are we still going to have the most likely scenario or the lesser scenario? So this is part of what we have to understand and be able to adapt our plans to. And in order to be able to do that dynamically, we have to institutionalize, or another term, operationalize asset management. And in order to do so, right now, the maturity of practice of asset management is not sufficient by and large across the board to be able to do that. So we have to invest more time and effort in something that we already are doing, that we already need to do, legislative or incentivized. So let's continue that asset management journey and make that effort to make that work for us for this specific problem, as well as other problems that we have around infrastructure.
All right, that's great. So,
Okay, so
I'm gonna move along just because I'm getting the hook there from Ken. So that really lays out, process in a nutshell to capture the risk. And I guess I'm gonna go to Nicole and say, okay, so you can look at it almost from a little different point of view. And my question would be, do we need all these assets, or is there a different way to get at the problem other than an asset? But you carry on. That's just sort of a thing that's always been bugging me. So.
Yeah, so the town of Collingwood's we have a growing population, and we expect it to grow for the next at least 20 years. So whether we like it or not, we're going to be investing time, money, energy into this new growing population. So the question is, how do we build resilience in the infrastructure that we're already going to invest in to support the population? So I'd say the traditional thinking was build stronger. let's build stronger walls, stronger buildings so that we don't have to deal with the impacts of climate change. But when you do factor in climate change, you really want to look at the mitigation and the adaptation. And what I mean by that on the mitigation side is how do we stop or slow the path that we're already on? So a fellow panelist mentioned retrofits and building envelope, getting off natural gas, reducing reliance on fossil fuels are all examples of mitigation efforts that we can do. And then the one that's gaining a lot more traction now is adaptation. How do we change the way we build? So I see that through two lenses, through green infrastructure, which I'll loop back to. But the one I'm really interested in is how do we design communities differently? So when you look at a lot of cities right now, we see if we take Toronto, for example, an urban core surrounded by that, other than the water, is suburbs. And then every 10, 15 years, you get sprawl. So the urban core gets a little bit bigger, and then the suburbs sprawl out onto the farmlands. I've lived this. I'm born and raised in Caledon, and I see Brampton creeping in. Over the last 10 years, you wouldn't recognize where I grew up. And we're still living in the same house. So we see that urban sprawl. And then with that comes a large reliance on cars. When I turned 16, the first thing I did was get my driver's license because in Caledon, there's no public transportation. And if I wanted to go anywhere, I needed a car. So you see that too. People from Brampton, Mississauga, Caledon, all driving into the city to work, to have fun, to go to the hockey game, to go to the baseball games. There's such a reliance on cars. And what is normally a 40-minute commute from point A to point B without traffic turns into an hour and a half, 2 hours. People dread getting into the city. And I'm not just talking about Toronto. This is for a lot of cities, at least in North America. So what happens if we design communities with people in mind first? So how can we live, work, learn, play, take our kids to daycare within a 20-minute walk from each other? And also have reliable public transportation. So if we were to build communities in a different way, where your workplace was 15 minutes away, your groceries were a 5-minute walk away, your kids' daycare was 10 minutes, would you own a car? I'm getting some shakes, no. I got a nod, yes. So I understand both points of view. You might still want a car, and there will be some amenities that are outside of that 20-minute walk. But for a lot of people, within that 20 minutes, that's enough. When I went to university, I went to the University of Ottawa, right downtown, and one of my biggest fears was not having access to a car. And I understand that's a very privileged stance that I was in, but I didn't have a car for 5 years there. And other than winters and poor public transportation at times, it was manageable. I could walk anywhere I needed to. So designing cities in a way that we can walk them and that everyone can get around in. So ensuring that our sidewalks are accessible, people with wheelchairs can get around. I think that's another way to look at infrastructure, where let's not just build close to the waterfront where we know that flooding is going to happen. Let's build complete communities in a walkable distance with reliable public transportation and get away from the idea that cars are our lifeline to freedom.
All right. How's that? We came in pretty close, eh? All right. Yeah. I think this was great. You've had different perspectives on sort of how to tackle a very significant, huge problem from all different angles. I'm going to touch on the car thing real fast because that's a cool one. So I work in Toronto, but I do live in Ottawa. I try to take the train. I really do. But sometimes I drive. But in Ottawa, I live close to stuff, but I take the car, not only because it's like 1,000,000 degrees below zero, but it's just there and I can park. And I live near downtown Toronto here, and I can't park. So I don't bother taking a car because it's just a pain. Now, of course, if I didn't live in downtown Toronto, I might feel differently, but it really does resonate. The habits really do change. So I'd like to thank our panelists and very much. So quick round for these different perspectives. And hopefully come away learning something, and we're all around afterwards if you want to have any more questions. Thanks, Ken.